Hey physics students, so here is a video on basically the three types of graphs that we're going to have: position versus time, velocity versus time, and acceleration versus time. And so this video is about what information we can gather and how to use it. Let's go. First graph, position versus time. So if I have a position versus time graph, which we abbreviate xt, and this is in meters, position versus time graph would look maybe something like that. Now the y-intercept is something that we're looking for, and in general the y-intercept is the starting blank. So for this case, position versus time, it's the starting, well, position. And so the starting position is essentially where it's located. Now we abbreviate position with x, and so if I call it xi, that's the starting position. Okay. Now, if I have a similar looking graph, say like this, but it's a velocity time graph, well, this same dot, that same starting blank, in this case, it's starting velocity, since it's a velocity graph. So now, in this class, by the way, velocity is measured in meters per second, and position is labeled in meters. Okay. Well, starting velocity, we use the abbreviation VI, which is the same thing as starting velocity, but in this case, it's the initial velocity. Okay. Now, acceleration, no different. Most of our acceleration graphs will look something like this, possibly. Okay, and that acceleration graph, you guessed it, that intercept is the starting acceleration. Which is A, and that's in meters per second squared, meters per second per second. Oh, sorry, didn't realize that was there. Okay, so that's what you can get with the y-intercept from each of these. Now I want to go back to the position versus time graph and take a look at this. Okay, because again, when we look at position versus time, and if I look for what the slope means, position's in meters, time is in seconds again. So position versus time, if I look for the slope, I know it's the rise over the run, and if I'm looking at rise over run, that's going to be meters over seconds. So meters over seconds, or meters per second, which is velocity. Okay, so if I look at the slope of any position versus time graph, that will tell me what the velocity of the object that's being described. Okay, now lastly, information that we can gather from the area under this graph. I'm going to go ahead and show you this once. Position in meters over time in seconds. Let's say I have a graph that looks something like this. And so if I wanted to find the area here, I'd ultimately be taking time, seconds, times meters. So seconds times meters gives us, I don't know what that is. And that's the point, okay? This means nothing to us. There's no such thing as a meter second, second meter, whatever you want to call it. So if you take the area under this graph, it really tells us nothing. Now, on the other end of this, area under these do mean something, and we'll talk about that in a moment. Okay, but back to this. So the slope of a velocity versus time graph. So if I have a velocity graph, let's say that looks like this, okay, which, by the way, I have one up right here. So this is an example video of me throwing a ball up. Okay, and the motion tracking happened. We created a graph. Here's my velocity graph. So the slope of this graph, let me get it for you, is labeled in meters per second per second. So the slope is negative 11.8 meters per second of this graph, which is exactly like the graph I drew. So again, the slope is rise over run, and my rise is the velocity, which is in meters per second, and my run is in seconds, which is meters per second over seconds. Now that's the change in speed over the time that it happens. So it's the rate of the change of the speed, which is acceleration. So acceleration is in meters per second squared, which is exactly what this is. And therefore, if you find the slope of any velocity graph from here on out, you're finding acceleration. Okay. Now lastly, if you look for the area under a graph, think back to our last unit. If I have a velocity time graph and I find the area of this box, well, that gives me the displacement. Or we call that delta x. Now again, this is going to be labeled in meters. But that said, we're in a new unit now, and sometimes we're going to have graphs that say, look like this. We can still find that area, but we just have to use a little bit different math to do so. Okay? We'd use the area of a triangle, 1/2 base times height. Now the last section, acceleration graphs. So this whole column here is acceleration graphs. Information we can get from the slope of this graph. Well, let's take a look once. Let's say we have an acceleration graph that looks like this. So it's meters per second squared and seconds are our labels. The slope would be meters per second squared over seconds, which gives me meters per second cubed. So meters per second cubed is something that we call jerk. Basically what that is it's accelerated acceleration. Now this one you don't necessarily need to know because we don't use it, but this is kind of FYI. So this is not used by us very often. Okay, now that said, if you know what it is, great. If you don't, you can leave it. But it's accelerated acceleration. It'd be like if you were pushing the gas pedal on your car and you were pushing it harder and harder and harder, and you were changing the rate at which you were accelerating the vehicle. Now the last part, if I have an acceleration graph, and let's draw one that looks like what we would have. So if this is my acceleration, meters per second squared, and this is my time in seconds, okay, if I were finding the area here, I would effectively be multiplying meters per second times seconds, meters per second squared times seconds. That would leave me with meters per second, which is a form of velocity. And actually, in fact, if we're looking at the change in velocity, this area would be what it would be showing. So change in velocity, okay, or delta V as we use it. So this is all of the information that you can gather from all of these different graphs. Now, just again to kind of reiterate what I'm trying to show, all of this information here is regarding a velocity or position versus time graph, x versus t. All of this information here is information we can gather using a velocity versus time graph. And then lastly, all of this information here is information we can gather using an acceleration graph. So hopefully you guys are able to fill this out on your own now. It should be helpful. Thanks for watching. Over and out.